first of all, as lesson 6.5, so that you know when you look on this page in your notebook, what is it? And we're going to show what is the skill, what is the learning goal that we have today. It's called, our learning goal is multiplying a polynomial, multiplying a polynomial by a monomial So that's our learning goal today. That's the skill we should have. Learn today, practice today in your homework. And to accomplish it, we're going to need to do distributive property. And we know how to do distributive property. Distributive property is multiplication over addition or subtraction. The problem is you're going to be auditory learning and copying it in later. So I asked you to open your books to page 423. So what we're going to do is we're going to do the check it out. Found on page 423. So we're doing the check it out, page 423. And we're going to start with 2A. You guys did the types of problems that example 1 showed. That was what we studied to help us with those. So we're going to do 2 ones like example 2. So we'll start with 2A. So go ahead and write down the problem as it is given to you on that page. Check it out. Make sure you're finding the right spot. You should be doing check it out and make sure you have 2A. Now there's a certain amount of our work that we're going to do mental math. There's other parts of our work we're not. We're going to show what we're doing. Even though you'll be like, this is so easy, the easier ones are going to seem like, doesn't seem necessary. But then they're going to get harder, and we need to know a good process to follow. So when we do distributive property, first of all, before we even do it, we always want to make sure, do we have any subtraction to change to add the opposite? Do we this time? No, so we can go straight to our distributive property, which says we have to take that monomial times the trinomial we have, so we're going to have 3 multiplications. So however many terms our other polynomial has should be how many multiplications there are. So we're going to have 2 times 4x squared, and I want you to put a box around that. I want you to see that you're going to have, this kind of helps separate because there's going to be so much going on. It's going to look like a run-on almost, or a mismatch of things. 2 times x, the second term has to get multiplied by 2. Bring down our addition sign, and now we have to take the 2 times the 3. So because we're multiplying a monomial times a trinomial, there better be 3 multiplications set up. Here's where we'll do the, kind of like the mental math in our head. We'll say, okay, what is 2 times 4? Oh, in this one we can do that because it's just a constant. This one is 8x squared. 2 times x?
2x.
2x. And 2 times 3?
6.
6. So here is our final answer. If it doesn't need any cleaning up. Did I circle it too early? Does it need any cleaning up? No, it's all addition, so it's a good answer as it is. Okay, that time we were just actually multiplying a constant. That's what our monomial was a constant. Monomial times a trinomial. And so it wasn't probably as hard as they are going to get. Okay, go ahead and write down problem 2B. And you always want to make sure you carefully write down the problem and double check it before you start to set yourself up for success from the beginning. Any subtraction?
No.
How many multiplications should there be? 2. We are taking a monomial times a what this time? Binomial. So we need to have 2 multiplications set up. So we're going to have 3ab, and that's all we're going to do right here is just show that we're going to take 3ab times 5a squared. That's our first multiplication. And our other multiplication is that 3ab again, our monomial, times the other term of our binomial, b. So there's our 2 multiplications. Now we'll show the work like we did for today. Now this might be where, Trey, you want to jump on board and do it like us, or you can keep doing it the way you were. I think my paper would get too busy if I was trying to do it that way, but if it works for you, go ahead and do it. We're going to, within this one, we're just going to rearrange it. We're going to have 3 times 5. And we're going, just like we did for today, and we're going to have a times a squared. And we're going to have b. So this is how we did it for today. We gave groups in parentheses. We put together groups of things that could actually be multiplied times each other. So the 3 can get multiplied by the 5. The a can get multiplied by the a squared. The b doesn't have anything to be multiplied. Yes?
There's a video, but that was like you take the 3 times it by the 5, you take the a times it by the a, and then there's another b. Right there. Okay, on the b for the 3.
That's in this one. That's in the other multiplication though. We're just dealing with this multiplication right now. There's not another b to be multiplied times that one, is there? Okay. Maybe I'm misunderstanding your question. If we move on, let's bring our plus sign down. If we move on to our other multiplication,
okay.
Does that 3 have anything really to be multiplied by? No, so we'll just leave it in its own group. Does the a have anything to be multiplied by? No, so we'll leave it in its own group. And we have a b and times another b. Okay, now we will do our multiplying. What is 3 times 5? 15. Okay. A times a squared. A to the 3rd, a cubed. And that b doesn't have anything to be multiplied by. Bring down our addition. 3 doesn't have anything to be multiplied by. A doesn't have anything to be multiplied by. B times b, b squared. And can it be cleaned up?
No.
How do we know if these guys can be added together? There's 15 of these, and there's 3 of these. How do we know if they can be put together and say there's 18 altogether? How do we know? If what's the same? The variable part. Are a cubes b the same as ab squareds?
No.
In other words, do these parts match? Do the variable parts match? A cubed b, is that the same as an ab squared? No. So we stop and say, you know what? There's our polynomial answer, our product. Okay, anybody have any questions about either of these before we move on? Trey,
How do we put them together?
that's what we were just talking about, how
Like just multiply.
multiplying?
Like we did.
Because there's no multiplication going on here. The multiplication is taking those times each other. But that addition is between the two multiplications. That just keeps coming down, all the way down.
So that's why you separate both of them and made it into two different equations.
That's why we make them into two parts, because it's two multiplications that have to be added together, even though in the end they really can't be added together.
We're gonna keep it back to the first one. And that's the same too.
Same thing here. We had two addition signs. We had three multiplications. So 1, 2, 3 multiplications, 2 addition signs. So we don't want to lose our addition signs.
And would you add if that 2x had a square?
Then we could put it together with the 8x squared, but it doesn't, so we can't, right?
So it would be like 10x
10x squared.
plus 6.
If we could, we would do that. Yep. Okay, anything else? Okay, let's move on to 2c then. Let's do that one now. 2c. Where'd that color come from? Oh, there we go. Okay. Love when they use S's, and then they also use 5s in the problem size, because 5s can look like S's. You gotta be really careful. Make your 5s bigger, make your S's smaller, and try to make sure you can tell the difference between them. Okay, how many multiplications do we have this time?
2.
2. What are we gonna do with that subtraction inside that
Add the opposite.
binomial? We're gonna change it to add the opposite. So let's just go ahead and do that right away. Let's change that to add the opposite. And then let's set up our 2 multiplications. So we have 5r squared s squared that has to get multiplied. I didn't want to do that. It's a pretty, it's got a few pieces to it, so we want to make sure that has to be multiplied. That monomial has to be multiplied times the r, the first term of our other polynomial. So there's one of our multiplications right there. What do we do next? What do we have to make sure we bring down?
Negative 3s.
No.
The 5r times 5.
No. What do we have to bring down before?
Plus, plus, plus.
The addition sign. The addition has to come in between our multiplications. And now we're going to take 5r squared, s squared, times negative 3s. There's our other multiplication. Yes, Mel?
Do you separate?
Separate what? What do you mean by separate?
Oh, never mind. See the
But the next step, I think that might be what you're talking about. Rearrange them?
Yeah.
Yeah. So now the next step, we're going to rearrange them. We're going to, is that 5 have another constant to be multiplied by? No, so it's got its own group. No plus signs in here, okay? We're just rearranging. It's still all multiplication. Parentheses next to parentheses mean multiplication.
R.
The r's, so we have an r squared times another r. And then we have only the s squared. There's nothing there to group with that one. So all we're doing is rearranging our first multiplication.
And then 3. Negative 3.
And then we bring down our addition sign. And we're going to group together the 5 and the negative 3. They can be multiplied times each other. R squared doesn't have any of the r's. S squared times s. Okay, go ahead and finish up and let's see if we all get the same answer. And if your answer needs cleaning up, clean it up. Also, let's keep practicing. I didn't take points out for not cleaning up on the quiz, but I'm maybe going to start some point, so we want to keep practicing cleaning up.
You can't add the r's, can you?
You mean add the r's?
Like r plus r. You can't make like 2r or something. It just stays r squared. Because the power of the square the other R doesn't have. So they're not the same.
They're not the same, but they have the same base, so what can r squared times r become? So what's the product of the first multiplication here? Tell me what that one is. What's 5 times the r's times the s's? Cameron?
5 r to the third s squared.
Okay. 5 r to the third. I'm going to erase that a little bit because I told you not to do that, and I shouldn't either. Make the s's smaller so you can tell that they're not the 5. So 5r to the third power times s squared. That's our first product. What's our second product? Shmarky?
Negative 15 r squared s to s cubed.
Okay. Okay, are those like terms? The variable parts have to match exactly. Are r cubed s squareds
So negative.
the same as r squareds s cubed? No, they don't match. So now we can't put them together, but we can clean this up. How are we going to clean it up? Isaac? Can we add them? Did we just talk about that? Can we add them together? Cameron?
Change the plus to a minus.
So just change the plus to a minus. That's all I got to do.
Get rid of the negative sign.
Yeah, this also has to change to its opposite, doesn't it? We don't want that there. We got to get rid of that. This, the opposite of negative 15r squared s cubed is positive 15r squared s cubed. And now we have our answer cleaned up.
The r is not the 5, is it? The r is its own.
The r is it alone?
Like yeah, like if 15 and like 5, like you know how 5 is r squared? I mean r cubed.
Yeah.
If that was r squared, what would it be? Because
Well-
the other one is r squared.
Okay, but then even if this was an r squared s squared, our r squared's s squared is the same as r squared s cubes. They have to match exactly. Do they match exactly?
No.
No, they have to. The variable parts have to match exactly for them to be like terms. Okay?
So just one of them can.
Yeah, you
Match.
can't even be off. Just not even just one part of it. The whole thing has to match. The whole thing. Emerson?
What if they were the same?
Then we could take their coefficient parts. So if these were the same, then we would say, what is 5 plus a negative 15? And we'd get a negative 10, and then we say we have a negative 10 of whatever that same variable part was. Okay? Just like if we add 5x to negative 15x, because they're both exactly x's, we can add their coefficient parts and keep them as x's. So all good questions. Anything else? You're going to do one more. Go to page 427 in your books. And we're going to do it together because it's a little bit challenging. But I would like you to put that we are doing, I want you to put that we're on page 427 now. And that we're going to do problem number 12. So you're going to have something like this in your homework, and I want you to practice it with me. Okay, so write down problem number 12, found on page 427. Okay. Now, what comes first, multiplication or subtraction?
Multiplication.
Multiplication. Okay. Anybody think they know what we could do as a first move here? There's actually a couple of different things we can do, but so let's explore what are those. Cameron.
The subtraction and this.
Okay, that would be a good place to start there. Let's change the subtraction to add, and it'll become a negative n. Okay, I think.
Take the 5m to the second power n to the n cubed times that m n to the second power.
This, what's going on here is when we have multiplication, what we really have here, you guys, is we have three factors going on, and you can multiply in any order you want. What we really have here is we have this is a factor, this is a factor. We could stick a multiplication dot right here, and this would be a factor. So we really have three factors in a multiplication problem. We can multiply them in any order we want. Let's start by just taking these first two times each other. So let's put a box around that we're going to take 5m squared n cubed, and we're going to multiply that times mn squared. Let's just do that first, and then let's leave this over here waiting for us, okay? So let's do our multiplication, the first two factors. Let's multiply them times each other. Because of the commutative property of multiplication, says you get to multiply in any order you want. It just so happens that in one of our factors there's an addition. So we'll deal with that later. So remember, when we're multiplying monomials, we group together things that can be multiplied times each other. When we're multiplying monomials, we group together things that are like each other to multiply them. And then we'll just drag this along with us. We don't want to forget about it. Just drag it along. Hey, how about we put a 1 in there in place of that negative n? Let's put a 1 in there. Slip that in right now. Okay, what's this product over here? When we have a 5 times these m's times these n's, what's the result? What's the product? Josh, what do you get?
I got 5m cubed, 9 to the top, or n to the top.
Okay, I agree. 5m cubed n to the 5th power. Now we have that times our 4m plus negative 1n. So in reality, now we have a monomial times a binomial, don't we? So we have a monomial 5m cubed n to the 5th times that binomial 4m plus negative 1n. Same thing we've been doing all along. Now we're going to do our distributive property. We're going to take this and multiply it times both of those. So we're going to show our 5m cubed n to the 5th has to get multiplied times the 4m. There's one of our multiplications. Bring the addition sign down to be in between them. And that 5m cubed n to the 5th now is going to get multiplied times the negative 1n, our other multiplication. Okay, go ahead and finish that one up. Let's see if we all get the same answer. You know what kind of work you have to show. If I need to be challenged, make sure you let me know. If you look up at some point and say, that isn't what I got. See who's right. And my answer is gonna be cleaned up, so yours should be able to be also. How would we see the answer in the back of the book or in an answer mail? Do you agree with me?
Yeah.
Okay. If and when you agree with me, you can get out a sheet of loose paper and start on the homework. If you're not done, or you don't have the same answer I do, you need to figure it out before you move on. Okay? I am gonna stop the recording and then I'm gonna put it back up for you. I won't lose this, but I will lose it for a little bit. Just to stop my recording.